I would like to explain Green's theorem. Green's theorem states that if phi and psi are two scalar point functions such that these functions and their first derivatives are continuously differentiable in a region bounded by a closed surface S, then we have volume integral of phi del square psi plus del bar phi dot del bar psi dv is equal to surface integral of phi del bar psi dot ds bar. In this mathematical form, del square is an operator called Laplacian operator. Del bar is called vector operator called nabla. Del bar phi and del bar psi are the two vectors, even though phi and psi are scalar point functions. This mathematical form of Green's theorem is called first form of Green's theorem. The second form of Green's theorem can be written as the volume integral of phi del square psi minus psi del square phi dv is equal to surface integral of phi del bar psi minus psi del bar phi dot ds bar. This is the mathematical form of second Green's theorem. These two forms of Green's theorem can be proved by using Gauss-Divergence theorem. Proof: according to Gauss-Divergence theorem, phi volume integral of div bar dv is equal to surface integral of a bar dot ds bar. Because of del bar psi is a vector quantity, phi del bar psi will also a vector quantity. Let this vector quantity is denoted by a vector a bar. That means let a bar is equal to phi del bar psi. Now a bar can be expressed in terms of I bar j bar cover as I bar ax plus j bar ay plus k bar iz is equal to phi into del bar psi can be expressed as I bar dou psi by dou x plus j bar dou psi by dou y plus k bar dou psi by dou z. And comparing the quotients of I bar j bar k bar on both sides, we get ax is equal to phi into dou psi by dou x, ay is equal to phi into dou psi by dou y, az is equal to phi into dou psi by dou z. Now div a bar can be expressed as dou ax by dou x plus dou ay by dou y plus dou az by dou z. In this equation, substituting the values of ax, ay and az, we get div a bar is equal to dou by dou x of phi dou psi by dou x plus dou by dou y of phi dou psi by dou y plus dou by dou z of phi dou psi by dou z. In this equation, both phi and dou psi by dou x, dou psi by dou y and dou psi by dou z are variables. Hence, this equation can be expressed as by using product of two vectors as div bar is equal to phi dou square psi by dou x square plus dou phi by dou x into dou psi by dou x plus phi into dou square by dou y square plus dou phi by dou y plus dou psi by dou y plus phi into dou square psi by dou z square plus dou phi by dou z plus dou psi by dou z. In this equation, the terms can be rearranged as phi into dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus dou phi by dou x into dou psi by dou x plus dou phi by dou y into dou psi by dou y plus dou phi by dou z into dou psi by dou z. This can be simplified as div bar is equal to phi del square psi plus del bar phi dot del bar psi. Now from equation 2 the value of a bar and from equation 3 the value of div a bar are substituted in equation 1, we get volume integral of phi del square psi plus del bar psi dot del bar phi dv is equal to surface integral of phi del bar psi dot ds bar. This is the first form of Green's theorem. Now to prove second form of Green's theorem, in equation 4 the scalar functions phi and psi are interchanged, then if we interchange the scalar functions phi and psi, we get the volume integral of psi del square phi plus del bar phi dot del bar psi dv is equal to surface integral of psi del bar phi dot ds bar. Now substituting the equation phi from equation 4, we get volume integral of phi del square psi minus psi del square phi dv is equal to surface integral of phi del bar psi minus psi del bar phi dot ds bar. This is second form of Green's theorem. Now in this vector analysis chapter, previously I had explained the important quantities, important terms: gradient of scalar field, divergence of vector field, curl of vector field, line integral, surface integral, Stokes theorem, Gauss-Jevons theorem and Green's theorem. These are the most important topics in this unit. By using these topics, we can solve some important problems. These are the very important in the examination also. Some problems I want to discuss some problems in the vector analysis chapter. They are: first problem, if r bar is a position vector of point, then evaluate grad r and grad 1 by r. So solution: how to solve this problem? In the given data, r bar means a position vector of a point. R bar can be expressed in terms of I bar, j bar, k bar as r bar is equal to I bar x plus j bar y plus k bar z. Then the magnitude of r bar can be expressed as r bar is modulus of r bar. That means r is equal to modulus of r bar is equal to square root of x square plus y square plus z square. This is the magnitude of r. Now grad r is equal to del bar r is equal to I bar dou by x plus j bar dou by dou y plus k bar dou by z of x square plus y square plus z square whole power half. We can differentiate the above equation. We get I bar into 2x by 2 into x square plus y square by z square whole power half plus j bar into 2y by 2 into x square plus y square by z square whole power half plus k bar into 2z by 2 into x square plus y square by z square whole power half. We know that x square plus y square by z square whole power half is equal to r. So when LCM is calculated, grad r is equal to I bar x plus j bar y plus k bar z by x square plus y square by z square whole power half, that is equal to r bar by r, that is equal to r cap. That means the gradient of r is equal to r cap. Similarly, we can determine grad 1 by r. Grad 1 by r as minus r cap by r square. In this way, we can solve so many problems. Another important problem is if r bar is position vector of a point, then we can prove div r bar is equal to 3 and gradient of r bar dot a bar is equal to a bar. Div r bar 3 means r bar is equal to I bar x plus j bar y plus k bar z, then div r bar is equal to del bar dot r bar, that is equal to I bar dou by x plus j bar dou by y plus k bar dou by z dot I bar x plus j bar y plus k bar z. Now that is equal to dou x by dou x plus dou y by dou y plus dou z by dou z, that is equal to 1 plus 1 plus 1, that is equal to 3. Therefore div r bar is equal to 3. In this way we can also prove r bar div bar is equal to a bar. Now another important problem is if a bar is a vector is solenoidal, determine the value of constant c. A bar is equal to I bar x plus 3y plus j bar into y minus 2z plus k bar into x plus cz. Given that the vector a bar is solenoidal. Solenoidal means if di O bar is equal to 0, the vector A bar is called solenoidal. So di O bar is equal to 0 means del bar A bar is equal to I bar dou bar dou x plus j bar dou bar dou y plus k bar dou z dot I bar into x plus 3y plus j bar into y minus 2z plus k bar into x plus cz is equal to 0. On solving, we get 1 plus c is equal to 0 or c is equal to minus 2. Now another problem, if a bar is equal to 2x I bar plus 2y j bar plus 3z k bar, find curl A bar. Curl A bar means del bar plus A bar. The curl A bar can be determined by using a determinant. The determinant can be expressed as I bar j bar k bar dou by x dou by dou y dou by dou z, and the components of I bar j bar k bar of A bar is 2x 2y 2z. After solving, we get curl A bar is equal to 0 bar. 0 bar means null vector. So curl A bar is equal to 0 bar means the vector A bar is irrotational vector. Another important problem is, if R bar is the position vector of a point, then curl R bar is equal to 0 bar. This can be shown that R bar is equal to I bar x plus j bar y plus k bar z, then curl R bar is equal to del bar plus R bar is equal to I bar j bar k bar dou by dou x dou by dou y plus dou by dou z x y z. This can be expanded as I bar into dou z by dou y minus dou y by dou z plus j bar into dou x by dou z minus dou z by dou x plus k bar into dou y by dou z minus dou z by dou y. That is equal to I bar into 0 plus j bar into 0 plus k bar into 0. That is equal to 0 bar. That means null vector. Therefore, curl R bar is equal to 0 bar. In this way, we can solve so many problems. Another important problem is curl grad phi is equal to 0. Curl grad phi is equal to 0. That means del bar cross grad phi is equal to 0. Del bar cross del bar phi is equal to 0. That can be proved as curl grad phi is equal to del bar cross del bar phi is equal to I bar dou by x plus j bar dou by dou y plus k bar dou by z cross I bar dou phi by dou x plus j bar dou phi by dou y plus k bar dou phi by dou z. This can be expressed in terms of determinant as I bar j bar k bar dou by x dou by dou y dou by dou z dou phi by dou x plus dou phi by dou y dou phi by dou z. This can be expressed as I bar into 0 plus j bar into 0 plus k bar into 0, that is equal to 0 bar. That means curl grad phi is equal to 0 bar. In this way, we can solve large number of problems in the vector analysis. I hope this video lecture on vector analysis is very useful to understand the topics prescribed in our syllabus. In the examination point of view, the questions in vector analysis are of two types: short answer questions and long answer questions. Short answer questions carries 5 marks and long answer questions carries 10 marks. Short answer questions. First question, define scalar and vector fields. Give 3 examples each. Second question, define gradient of scalar field and give its physical significance with example. Explain the divergence of vector field and give its physical significance with example. Fourth question, define curl of vector field and give examples. Explain its physical significance. Fifth question, what are line integral, surface integral and volume integral? Give examples each. Long answer questions are, define scalar and vector fields, give examples of each, state and prove Stokes theorem. Second question is, explain physical meaning of curl of vector field with examples, state and prove Gauss-Jevons theorem. Third question is, state and prove Stokes theorem and Gauss-Jevons theorem. Fourth question is, define surface and volume integrals, state and explain Green's theorem, prove that curl of a gradient is 0. These combinations may be vary in the examination. So if we read the questions in this type, you can give answer easily. Thank you. All the best.